Hey, today we're going to look at lesson 11, functions, and let's see, what is this? Oh, 19 problems. Wow. Okay, usually 15. There's more here. So I'm going to start off by defining what a function is. There's a few ways of defining it, and here's how I'm going to go about it. I'll state a couple of definitions before it's all over. A function is a rule which assigns each x value exactly one, not two or three, only one y value. Function is a rule which assigns each x value only one or exactly one y value. The set of x values we'll call the domain. The set of y values we'll call the range. Now this is a combo college algebra, intermediate algebra class that you're taking right now. And this is one of the topics that's listed as you look at the learning outcomes on the syllabus for both intermediate algebra and college algebra. So that's why there's 19 problems on the assignment, maybe a little bit more than usual, because some's intermediate algebra, some's college algebra. Okay? Let's look at a problem. So a function is a rule which assigns to each x value exactly one y value. Not two or three y values, exactly one. Let's see if I can make this. Okay. Okay, so this is problem number 1. It says determine whether this correspondence is a function. They're using the word correspondence the way I use rule. So problem number 1, let me write it down. The domain, I'll just write D for domain and R for range. 12, 18, 13. Oh, I'll switch it in a moment. I just want problem. Let me see. Oh, okay, let me see. 12, 18, 13, 15, 20. Okay. Wait. 18 goes to 20 and 13 to 15. Oh, heck, this is a yes, no. You have a 50-50 chance of guessing at it. But hopefully you won't have to guess at it. Oh, wait a second. Oh, and let me get rid of this, and let me move it up some. Okay, a function is a rule which assigns each x value only one, exactly one, not two or three, just one y value. So over here it's labeled domain. So these are the x values. So let's look at these arrows. And over here are the y values, the range. How many y values is the number 12 being assigned? Just one, right? What about the number 18? How many y values? Just one. What about the number 13? Just one. Is each x value assigned only one y value? Yes. This is a function. The natural question is, well, when would it not be a function? Well, if there were two arrows coming out of either number, any one of these x's, then it would not be a function. Okay? Like if 12 were also being assigned 20. Or if 18 were also being paired with 15, then it would not be a function. 30 was paired with 15, but if it were also paired with 20, there was this little line here. If that were there, then not a function. Oh, I thought I was writing it real dim, but now it looks a lot darker than. So if this line were there, then it would be not function, but it wasn't there. On the one that's on the problem, your answer is yes, it's a function. Okay? But if there had been a line from 13 to 20 also, or if there had been two lines out of 18 or 12. So is this a function? Yes. Problem number 2. Since the definition of function talks about assigning each x value exactly one y value, when you think of x, y, you think of ordered pairs. So on this one, problem 2, let me write it down. It says determine the domain and range and then tell whether the relation is a function. Well, they're using the word relation. They're using every word except rule, which is the one I used for the test. For the definition. So this one, it says find the domain and the range, and then answer, is it a function, yes or no? Okay. 1, 3, 24, -9. I'm checking to make sure I didn't miscopy it, because I'm about to bring up what I've written here. Okay, so this is problem number 2. It says find the domain. Okay, that's the first thing we're told to do. Okay, the domain, those are just the x values. And I believe it tells you also here when you're stating the domain, use a comma to separate the answers. Type each answer only once. So if there's an x value repeated, you don't write it twice. You just type it once. So write down the x values: 1, 24, 44. Wait, another 1. So don't repeat that one. And what's the next number I'm going to write? 53. Those are the x values. Oh, let me go ahead and type those in so you can feel confident I'm doing this right. 1, comma, 24, comma, 44, comma. If you type a 1 in again, it's going to say wrong, and it actually tells you, if I'm remembering correctly, don't type the same answer more than once. Okay. Now for the range. Now I'm going to write down those numbers. This is a problem you can almost do without writing anything down. 3, just type it in, -9. Don't type the 3 again. And then 6. So 3, -9, 6 is our domain. 3, comma, -9, comma, 6. Is this a function? Well, I like that little arrow thing here. If there's just one arrow from each x value, then it is a function. But if there's one number that has 2 arrows or more than one arrow, it's not a function. So let's draw the arrows. Like this one here. 1 is paired with 3. Let me lift this up. 24 is paired with -9. 44 is paired with 3. 1 is paired with 6. And 53 is paired with 6. Is this thing a function? No. Which x value is being assigned to y values? 1. The number 1 is being assigned the y value of 3, and what else? And 6. Because of this red arrow here, the answer is no. Is it clear why I'm saying this is not a function? Because the x value 1 has 2 different y values. Okay? So let me say no to that. Oops, no. So no, it's not a function. I'm wondering, could y'all figure out a way to answer this question, is it a function, without drawing the arrows? Look at this set of ordered pairs. Could y'all come up with a rule to decide yes or no, it's not a function? What about this set of ordered pairs made it not a function? The repeated x's. Okay? So here's a way, some people, if you go and find a paper algebra book, every algebra book in the English language has a section called functions. If you look up the definition of function, it's going to say either what I said, a rule which assigns each x value exactly one y value, or here's another way you'll see functions defined. Let me write it out. Okay, so here's another way to define function. A function is a set of ordered pairs in which no x values are repeated. This one right up here. You can look at the set of ordered pairs and say, hey, wait, here's 2 ordered pairs with the same x value. So, not a function. And this is the way that half the algebra books out there would define function the way I did to begin with, a rule which assigns each x value exactly one y value. The other half are going to say set of ordered pairs in which no x values are repeated. Now, while I'm looking at this first definition up here, what were the words they used instead of rule? Correspondence. And I think they also said relation. Okay. I say rule. Okay? But it means the same thing. Now, on Monday we were graphing circles. So, here's a question for you. Here's a question. I want to ask y'all, are circles, what do y'all think? Circles functions. Are circles functions? Remember, I'll post these notes, but I'm writing here under where on my math lab? Where did I post it? Remember what it's called? Document sharing. Yeah. Okay. Are circles functions? Well, with a function, there should be no repeated x value. I'm going to use that to answer this question about circles. Let's try to picture the x axis and the y-axis, and let's just draw a random circle, okay? So here on this x-axis and y-axis, I'm going to draw a circle. Pretend it's a circle. It's going to turn out looking more oval than anything else, probably. Okay. Now, I should look to see if I have some graph paper to do this. But okay. Is this a set of ordered pairs in which none of the x values are repeated? If there's any repeated x's, it's not a function. Well, since I don't actually have all the numbers labeled on here, 1, 2, 3, 1, 2, 3, so forth, let's look at the y-axis. Right there, that point. Could y'all write that as an ordered pair? What does this ordered pair look like it would be? The 0, 3. Okay. What about this one right here? 0, -3. So, if there's repeated x's, it's not a function. Repeated x's. Are there repeated x's here if we started writing out the ordered pairs? There certainly are. Okay? So to answer the question, are circles functions? No. Okay? There are repeated x's. Now I said look just at the y-axis, but there's really nothing special about the y-axis. Could y'all picture drawing a line right here through the number 1 on the x-axis? Like right here. Can y'all tell this is red dots I'm drawing there? Well, maybe not. But here are 2 red dots, and both of those have the number 1 as their x value. So those are repeated. Here, these 2 points have the number 2 as their x value. Okay? In general, if a vertical line intersects a graph more than once, the graph is not a function. So circles are not functions. Well, we've also graphed lines, so here's another question. Are slanted lines functions? And then we'll get back to doing homework. Are slanted lines functions? How would I answer that? Well, just like with the circle, let's draw the x-axis and y-axis, and then just sketch any slanted line you want. I'll draw it right there. There's a slanted line. How many times did this slanted line cross the y-axis? Just once. What about any vertical line? If you draw vertical lines, are they only intersecting at once? Yeah. So slanted lines, what am I going to say? Yes or no? Are they functions? Yes. So this is something called the vertical line test that you can use to decide is a graph a function. And that's what we're about to do, starting with problem 3. Let's look at problem 3. It's just a yes-no question. And there's really no scribble on here. It's a V-shaped figure. Hey, do y'all remember from we did the graphing tools? What sort of graphs, which tool did we use that gave the V shape? Y'all remember? Absolute value. So here, is this absolute value graph a function? Well, There's a lot. I was going to say if you drew vertical lines, but heck, they're already drawn. Can y'all see the grid lines on this? Those vertical lines are only intersecting at once. So is this a function? Yeah, so number 3. I feel like I got to write something rather than just click this. Oops. It's a V-shaped figure. I may not have the exact numbers right on there. Something like that. So the answer on number 3 will be yes, but... Okay, so number 3, V-shaped figure. Notice it only intersects the y-axis in one spot. If you drew other vertical lines, they're only intersecting at one spot. So this one is a function. So let me see. Problem number... Is this graph a function? Yes. Final check. What about number 4? It looks sort of like one of my circles. It's not really a circle, is it? But if circles aren't functions, what do y'all think about this little thing? Is this a function? No. Look at the y-axis. Right there, it's crossed. There's 0, what is that, 0, 3 and 0, -3? There's 2 ordered pairs. So there's your vertical lines. So I'll just say, is this a function? What do we decide? No. Oh, have we done this one already? In a way, I think we have, haven't we? It says, decide whether this graph to the right defines a function. Well, what sort of figure is this? Slanted lines. What did we say about slanted lines? All slanted lines are functions. Okay? So let me see. Come back over here. And I'm going to see, is this a function? Yes. And there's more to it. It now says, okay, state the domain of this function. Okay? Or they are using the word relation. Oh, wow. I need to get out of the habit of saying rule. Okay, domain, those are the x values. If we look just at what's drawn right now, the x values are stretching from -10 over to a +6. But this graph, there's arrows. It keeps going and going and going. Okay? It keeps going and going and going. If I continue drawing this line out, it'll go from -10 to +10. If I keep drawing it out, would there be x values at -100? And +100? Does this thing keep going left and right? Did y'all hear that? That is right. For the domain, number 5. For the domain of a slanted line, it's always going to be -infinity, infinity. That means it keeps going and going and going, left and right. Does it keep going and going up and down? Because that's what the range is. I just keep drawing this out. Is it going to keep going and going up and going down? Yeah. The range here is also -infinity, infinity. Okay? That's how we're going to write out all real numbers in this course. My math lab likes that interval notation. Okay. So, what is the domain of this graph relation? Remember a few years back, I was at a Pearson thing, and they asked, is there anything you can think of that would make it easier on you? And I said, put a little hot button that just says parentheses, negative infinity, comma, infinity, close parentheses. And they just looked at me. I could tell they were thinking, this idiot. But it gets sort of tedious. By the time the semester's over, you'll see what I mean. You type, what did I do that? Negative infinity and infinity a lot. It would sure be nice if this symbol, all of this, was just one button here. Okay? So what I'm going to do, Control C it, and check. Maybe I should have made it a little smaller so y'all can see the whole thing. And right here, you can't do the right arrow copy and paste, but if you do the old-fashioned Control C and Control V, it'll let you copy and paste that negative infinity, comma infinity. That's what I just did, since there's not a button here for it. And you might think, oh, that's idiot. Trust me, by the time April comes along, you're going to be tired of typing in that negative infinity, comma infinity. Okay? Oh, I've moved on to the next problem. Any questions on this one here? So if someone says, say something algebraic and they'll think you're smart, you can say, the domain and range of a slanted line is negative infinity, comma infinity. Okay? Now let's see. What about this one? Oh, asks, is it a function? Well, so problem number 6. I'm going to draw it out. It won't look as good on my piece of paper as what's drawing up there for y'all. Problem 6. Trying to draw it so it looks like that thing there. Well, actually, maybe looking at this one would be the better way to do it. If you drew vertical lines, you don't even have to. It's showing the vertical lines. Y'all see the vertical lines? Are the vertical lines intersecting at more than once? Yeah, this thing is not a function. Okay? Here's what I drew. And, well, right there, the y-axis is intersecting it twice. And out here, you see, you can draw vertical lines to intersect it twice. So this one is not a function. So let's see. Is this a function? No. Now, the domain and range. Now, this is where it gets tricky, and you can figure out, do you understand what they mean by domain and range when they have a graph like that? Over here on this one, oh, yeah, I want to leave the question. I'll come back to it. On this one here, these arrows, it keeps going left and right. It's also going up and down. That's why the domain and range were both negative infinity, comma infinity. Over here, does this graph keep going? Is there going to be graph way over here? -3 to positive infinity. This graph keeps going further and further to the right, but it doesn't keep going to the left, does it? Where does it start? It starts at -3. Let me see. If I pop this out, will it make it any bigger? Or does it just pop it out? Y'all tell that it's the x values start at -3. Okay? And then they keep going and going and going. since there is, remember with interval notation, when you have a number, you have to put either parentheses or brackets. At infinities, you always put parentheses. This one's going to be a bracket. Why a bracket? Because there is a point. You're including -3. Bracket, -3, comma, infinity, close parentheses. And I just used the bracket from the keyboard. Okay. Look back at that once again. I'm saying, okay, looking at the x values, they're not negative infinity to infinity. Heck, there's nothing over here. The first x value occurs at -3. And then they just keep going and going to the right. To answer about the domain, the range, well, I sort of wish this graph had been drawn where it's obvious it's continuing to go up. Those arrows, it's going up slowly. It's going down slowly, okay? But it is going up and it is going down, which means the domain and range are what? Not the domain and range. What's the range? The range is just the negative infinity to infinity. I'd already copied that parenthesis negative infinity, comma infinity using Control C, and now I'm going to paste it again with Control V. So I don't have to paste that. Any questions why I'm saying this is negative infinity, comma infinity? What I'm saying is it's continuing to go up and it continues to go down. It'll eventually hit the floor and hit the ceiling, but it's just going up so slowly. Might would have been a better example if it had been drawn where it was really going up and down quickly.
Would it be wrong if it's got to be the negative infinity to infinity?
You've got to always put the smaller thing on the left. Okay? So if you say infinity, comma negative infinity, it's going to count it wrong. Okay? With interval notation, the smaller number always goes on the left. Okay? That's a good question. Another question? Let's see. What's number 7? Oh. Well, so that's the, the vertical line test. So there's several ways of representing these functions. At first glance, you might think this doesn't seem like a very major topic, but oh wow, yes it is. Every math course after this studies functions. It doesn't matter what course it is. Calculus, it's differential and integral functions. Trigonometry, it's the trig functions. Statistics and probability, that's all functions. So there's several ways of representing functions. You could do a graph, or you could write out the ordered pairs, or you could do this little diagram like this. But these only work if there's just, making a table like this wouldn't be that helpful if there were a few thousand. Listing out the ordered pairs, imagine if there were a few thousand ordered pairs, having to look and figure out, oh wow, what are the x values, what are the y values, and so forth. So graphs, that helps us get around having to have all these list of ordered pairs. This slanted line has a few billion ordered pairs on it. Okay? Quite a few billion. More than a few billion. Same thing here. Another way we can write functions is as formulas or as equation. So starting with number 7, we're going to look at something called function notation. Function notation. F parentheses x can be used in an equation or a formula in place of the letter y. Remember, each x value gets exactly one y value. This f parentheses x is not read f parentheses x. It should not read f times x. You can read it as function of x or just f of x. If we have more than one function, you can't call them all f. You'll need to be able to distinguish them. So the most common letters for functions are f, the three, just the next letters in the alphabet, G and H. And we'll see those used to represent functions. So, problem number 7. We're given a function, f of x equals 2x squared minus 3x. And we're told to find f of 0. Keep in mind that the original definition is that it's a rule which assigns each x value exactly one y value. Okay? Well, the number in the parentheses, that's the x. So when it says find f of 0, what it's asking you to do is find the corresponding y value. Your answer is going to be a y. What am I trying to say poorly that we're going to do with this 0 to find the y? Plug it in for x. Whatever's in the parentheses here, you plug in for x. And this might not be the best example in the world. Why? Well, what are we going to wind up with as the answer here? Yeah, if you put a 0 in for both of these green x's, 0 squared is 0, times 2 is 0, 3 times 0 is 0. So at first glance you might think, well, wait a minute, all I did was recopy the number. No, I didn't. I plugged it in. But there's more than one part to this problem. So I'm not just recopying the number that's in the parentheses. And hopefully this next one will show that. Find f of negative 1. Find f of negative 1. Well, what that's telling you to do is find the y value. What's the y value that's being assigned to the x value of negative 1? What's the y value? Find f of negative 1. Well, plug in the negative 1. Now be careful. When I put the negative 1 in for x, am I going to multiply by 2 first, or will I do the exponent? What's the order of operations there? The exponent. Okay? So negative 1 squared would just be positive 1 times 2 is 2. Now put the negative 1 in right here. Negative 3 times negative 1, is that going to be a plus 3? So what's the y value that's being assigned to negative 1? A 5. Y'all don't need to write this, but just to make sure it's clear, just like on problem number 1, you could be making a little table. 0 is being assigned to 0. Negative 1 is being assigned to 5. Each x value is getting exactly 1, or 1 and only 1, y value. So let me punch in that 5 so you'll feel more confident. 5. And there's still another part to this problem. Find f of 2. So if you know someone that's missed class and they ask you, how do you do this number 7? What are you going to say? Plug it in? Isn't that what probably you're going to say? You're not going to go into all that detail of every x value gets only one y value, you're going to say plug it in. Okay. Let's switch. So here, we're plugging a 2 in for x. Be sure to do the exponent first. 2 squared is 4. Times 2 is that going to be an 8? And minus 6. Oh, heck, this isn't a good example. Why? Once again, it might look like all I did was just recopy the number in the parentheses. No, no, no. Okay? So 2 is being assigned the number 2. So we're going to make a little function table like that. And I'm sorry, I'm cutting off problem 7. There. So 2. So whatever, when working with this function notation, whatever number's in those parentheses, you plug in for x. Here is number 8. Notice they're calling the function h instead of f. Okay, f, g, h, those are the common letters to use for function names. So here's number 8. H of x is x plus 7. We're trying to find h of 0. This one in particular, I've written it down and stuff, but more than likely you can do it just in your head without writing all of this, without writing down what I've done. Some of these problems you can just do in your head. Plug the 0 in for x, and what are we going to get? 7, okay? Seven. Hey, can we do this without writing it down? H of negative 12. What am I going to do? Plug a negative 12 in for x. Can y'all tell me what I'm going to have? Negative 12 plus 7. Did I hear negative 5? I agree with that. Negative 5. Oh, let's see. This next one. Easy or hard? It's not real hard, is it? What am I going to do with that negative 3? Plug it in for x. So negative 3 plus 4. Excuse me. Negative 3 plus 7. What am I going to punch in there? 4? Yeah. Sounds right. Ooh, what about this one? H of 18.
Okay.
25. Plug the 18 in for x. Whatever number's in the parentheses, you plug in for x. Now, this one I'm actually going to do. I'm going to write it out. H of y plus 2. This one is the one that can be a little tricky. Well, we've already... Oh, y'all caught up with me? Am I going too fast? Any questions? I've already said, whatever's in the parentheses, whatever number there, you plug in for x. But in actuality, whatever's in the parentheses, even if it's not a number, if it's variables, you plug that in for x. So to do h of y plus 2, you're going to put a y plus 2 in place of that black 7. So you'd have a y plus 2, but you still have the black plus 7. Now I can combine like terms and get what? Yeah, y plus 9. Okay. So whatever's in the parentheses, you plug in for x. Even if it's variables, you plug it in for x. So y plus 9. Y plus 9. this? No. Let me write this down. This is problem 9. Oh. They're using the letter K this time. The letter they're using for function, it doesn't matter. K of x equals 4x. And there's 3 parts to this problem. I like the fact that they show them all right off. So I can do all of, and then K of negative 18, K of positive 2, and K of 33. Okay. So finding K of negative 18. I'll do all 3 of them and then punch in the answer. Oh, I messed it up. I was trying to put the numbers in the parentheses in red ink, and I accidentally used black ink here. So when I tried to correct it, I got black ink on my red ink, and now it looks like it's black. But pretend it's red. Okay, whatever number's in the parentheses, you plug in for x. So we have a 4 times negative 18, negative 72. Yeah. So what y value is being assigned to negative 18? Well, this little formula assigns it negative 72. What's the y value being assigned to a positive 2? What would my answer for this one be? 8. 4 times 2 is 8. One more, K of 33. I better get rid of this black pen. I'm thinking that it's about to bust. Or maybe it already has. The way. 4 times 33. Say it again, 132. I agree with that. So we're just plugging the numbers that are in the parentheses in for x. So what were those numbers? Negative 72, 8, and a positive 132. Number 10. At first glance, it might look hard. But is it really a difficult one? Or is this one that you don't really need to write anything down? I'm going to write it down, but all I'm going to really do is just write it down and write out the answer. So number 10, it says, f of x is negative 4x plus 5. Find f of p. F of p. And just to make it look like I'm doing something, I'm color-coded it. In place of the blue X, I'm going to put what? Oh. Okay. Whatever's in the parentheses, you plug in for X. If there's a P in the parentheses, you still plug it in for X. So it'll be a negative 4P. In place of the X, I'm putting that that red P plus 5. Negative 4P plus 5. Just like over here, on number 8, we have that y plus 2. Whatever's in the parentheses, you plug in for x. So in place of the black X, I'll put that red Y plus 2. Over here, in place of the blue X, I just put the red letter P, negative 4P plus 5. This one here, what am I going to, this is still number 10. I'm not going to write it down, but just call it out. What am I going to type in there? Negative 5m plus 6. Negative 5m plus 6. Okay, now it's getting a little bit more involved. Problem 11. But remember what we said. Whatever's in the parentheses, you plug in for x. So let me write down number 11. F of x is negative 5x plus 6. Find and simplify f of, what's in the parentheses? 3b minus 5. Well, what are we going to do? Oh, let me lift this up so y'all can see it. Well, whatever's in the parentheses, you plug in for x. Well, that means in place of that black X, I'm putting all of that 3b minus 5. So I have the black negative 5. In place of that black negative 5, in place of that black X, I'm putting the red 3b minus 5. I still have the black plus 6. Instructions said to find it and simplify it. Well, there's some work to do to simplify this. What am I going to have to do? Distribute that negative 5, so we'd have a negative 15b and a plus 25. And don't forget you have that plus 6 there. Now combining, all I can do is combine the 25 and 6. So I'd have a negative 15b plus 31. Hopefully that doesn't look like a negative 156. Okay, it's a negative 15b plus 5. No, plus 31. Negative 15b plus 31. Whatever's inside those parentheses, you plug in for x. Right? Now, if it's just numbers in the parentheses, then, okay, you're plugging the numbers in. Each x value gets exactly one y value. If it's just numbers that you're looking at, the numbers in the parentheses are x, your answer is y. Right? Numbers in the parentheses are the x values, the answers are the y values. Let's see. Number 11. Oh yeah, okay, number 12. This one looks different. Here, the function is written as a set of ordered pairs. 9, 7, 3, 9, negative 4, negative 9. And we're told to find f of 9. This is going to be one that, boy, it looks like I'm just writing the answer down. Okay. I've written down the problem. Oh, but not in a way you can see it. Now, think about what this means. When there's just a number in the parentheses, the number in the parentheses is the x value. Your answer is what? The y value. So what this is asking is, what's the y value when the x value is 9? Did y'all hear 7? That's what I agree with. Yes, 7. What's the y value being assigned to the x value 9? A 7. Hopefully you're not thinking the answer should have been a 3. Over here, this 9 is a y value. And you're looking at the ordered pair for the x value is 9. So there's not a lot of really work to this one. Just type a 7. You know what? The answer is 7, but I want to do something, illustrate. There's been some questions. Okay, you typed the value of the first one. Okay, so they were able to figure out what I did wrong. They tried to tell me something wrong. Give me some hints on it. I'm going to make a change. Let's see, I wonder what would happen if I put a -3. Are they just going to say your answer is wrong? No, they're trying to talk me through it. Let me go ahead and just put a 9. At this point, it says final check. That means this is the last chance for me to get a green check before it tells me the right answer. Okay, the correct answer was 7. Under this circumstance, when you get the wrong answer, that's when you shouldn't do the thing they're suggesting. Don't move on to the next one. Go back and say similar question. Now, let's get this one right. Who wants to tell me what number I should type in for this? A 7. Okay? So I'll type in 7. Notice I have a red X, but once I reworked it with similar question.
Okay, this, I may sound like an idiot, but this kind of went over my head, this particular problem.
Let me change it. Let me get a different one without the answer. Well, looking at this one, the number in the parentheses is the X.
Okay.
Your answer is a Y. So it's asking, what's the X, or what's the Y value for this X value? Let's do a similar one. That similar question is always down here, that option, after even if you get it right. So, okay, let's say similar question. So, the X value is 5. What's the Y value? -3? Is that what I'm hearing? We'll do one more of those. Even though I got it right, I can always say similar question. I'll give y'all oh wow, which one? I'll give y'all some choices. Am I going to type -1 or -2 as an answer? What are y'all thinking? -2? The X value is -9. So what's the Y value? -2. Now, this is going to be one that it looks like I'm just going to be writing out there's no real work to it. I'm just going to be typing in the answers. Keep in mind that the number inside the parentheses is X. Your answers are going to be Y, just like over here. But instead of getting these ordered pairs listed out, you're going to have to look at the graph. Find this point where X is -4. Let's see. Where's X -4? It's right there. The Y value there, say it again, is 0. Okay? It's asking, what's the Y value at the point where X is 0? Now, Y'all mentally put the cursor where at the point that we're going to be looking at here to find f of 0. Well, there's the x-axis. I find 0 on the x-axis. It's this point right here. What's the y value there? 8. It's just not a lot of work to write out for this problem. I'm going to have to make it a little smaller because it's getting to where it's not. F of 3. Let me see, maybe if I pop it out to look at f of 3. What's going to happen? Okay. I locate 3 on the x-axis. That would be right here. Do you see where my cursor is? Let's move up until we hit the blue graph. What's the y value there? 2. You'll see why I'm getting 2 as an answer on this one. Type in 2. And one more, f of 8. Oh, maybe this is what I should be doing. Okay. I locate 8 on the x-axis. It's right here. I think this is the last point on the graph we're looking at. What's f of 8? 8. You'll see how I'm getting those. Oh, that's how I should have had it blown up all along. F of -4. Look at -4 on the x-axis. There's the point. It's 0. F of 0, the y value right here is 8. F of 3, okay, right, you got to find 3 on that x-axis. Hit the graph. The y value is 2. Any questions on how I'm doing that? So it looks like I'm just looking at the problem and calling out the answer. Diane. We'll pick up here after our break. At about 9:35, we'll pick up. There's one more topic left in this assignment. How to find the domain when the function is written as a formula. Okay? So don't let this scare you. It looks harder than it is. Okay? So it's time. It's after 9:20, so we'll take our break. I'll see y'all at about 9:35. Oh, let me go ahead and stop.